Let me show you how I built this really cool multi-user dinner coordination AI-enabled chat system using Google APIs for the places and the map, using Anthropic's LLM for the AI, and then using Convex real-time database for all of the database work. Convex is the sponsor of this video, and thank you so much to them. Technically, I gotta tell you, this project would have been a real pain in the butt without Convex. So let me show you how it all works and give you the code, and then you can try it out and build your own multi-user chat enabled application. Let's get right into it. All right, so I don't think a walkthrough makes a lot of sense in the world of LLMs and agents and agentic coding. What I do think makes sense is actually just kind of walking you through the application and talking about the high-level architectural points so that when you ask your agent to do stuff on your behalf, you understand what it's doing. So let's first talk about what the application is and what it does. Then we'll talk about how to get it set up, and it's super easy to set up. And then we'll talk about how it all works underneath the hood. Let's go check out the application. Here we've got two different users simultaneously. We've got Jackson and Joe, and they're both in the same chat, sharing the same thread, and each of them has a UI that's synchronized using the Convex real-time database. So on the left-hand side, you've got the chat, then you've got the restaurant map, where are the restaurants that we want to go to, where are they in town. Here we're showing Portland, which is where I live. And then you've got a short list for voting, which is actually a genuinely kind of cool app. All right, so let's talk about how to get it set up. The first thing you want to do is click on the link in the description right down below to get the source code from GitHub. You're going to want to bring that into your IDE, or I guess your Claude code if you're going to go that way. First thing you want to do is go and set up your environment variables. So after you've done your install, you're going to want to do a convex init and a convex dev to go and initialize those convex deployment variables. And you're also going to want to get a Google API key. So you're going to need access to the Places API as well as the JavaScript Maps API. You're also going to need an Anthropic API key. We're going to use Haiku, kind of keep the price lower. This is a 10-stack start application. It's what drives the UI. Where you do need that is actually up on Convex, because it's Convex that's actually going to be running all of the agent stuff. So let's go take a look at the Convex configuration. Now, Convex is open source. You can run it locally. I'm using the Convex cloud hosting. And as we can see, we've got some data in here. We have the thread that both of the people are talking on. We've got the short list of restaurants, including that Taste of Greek that was added, and we got the votes, 2 votes for Taste of Greek. So I guess they're going to Taste of Greek tonight. Actually, I've never been. I should go. Sounds really good. Then we've got our functions. These are the functions that can be invoked from either the client or the server that run in the Convex context. So for example, get or create thread would obviously get or create a thread. List all the messages in the chat is what you subscribe to get the list of messages in the chat. Then you see some of these functions are locked, like these places requests. Those can only be run by functions on the server, which is really cool because that means that the client can't run those functions. So if somebody hacks onto your client, they don't have access to all the different functions. You get to decide what they have access to. And then finally, a really important setup here is that you want to set the environment variables of that Anthropic key and that Google API key, since it's this Convex instance is actually going to be doing the calls to the LLM and to the Places API on Google. All right, so let's walk through a scenario. So let's say over here, I refresh the conversation and I say hello. What's actually happening here? So let's walk through that scenario. To help us visualize these flows a little bit better, I've created some draw.io diagrams. This one talks about how we send a message, like what we just did. So in this case, the browser is going to call the send message function up on Convex. That's going to be managed by the agent, which is going to go and add a item to the message list. And then that's going to get picked up by use UI messages, which is the real-time connection. That's the really nice thing here. The browser doesn't need to know that it has to go and get updated messages. It's automatically subscribed to those messages via use UI messages. That means that when you have multiple people on multiple browsers, like we have here with Jackson and Joe, it's automatic. So all of those browsers are subscribed using use UI messages, and they all update when those UI messages are updated. That's just part of the nature of the Convex real-time updating system. So over in the code, we have use chat input, and we bring in two things. We bring in use action from Convex React, so I can use the server action. And then I give use action the API chat.send message, and that gives me back a send message action, which I then invoke with my message. That's it. So now let's go take a look over on the Convex code. If I look at chat, we can see the corresponding send message function. This is actually running up on the Convex side. So the first thing it does is figure out whether that message has @AI in it. So it needs to know whether it's going to run AI. In this case, it doesn't. So what it does is it just calls save message, and then that adds it to the list of messages. And then if we go over to use chat messages, we can see use UI messages. It subscribes to API chat list all messages. You give it a thread ID. There's only one thread in this case. And then you say, well, how many items do I want? And do I want it streaming? And of course, yes, we do want it streaming. So we want the chunks to come in, and we want to get that AI result in real time. And it's just that easy. So let's talk about how AI fits into this. What happens when I hit @AI? How about Thai restaurants? We did a send message, sent that up to the server, and then the AI returned with its own messages. So how does all that work? So what's happening here is that same send message went up to Convex. The agent code then looked at that @AI and then fired off a request to the LLM. So let's take a look at it in code. So I go back in the Convex directory into the chat file, and now we actually do mention AI. So at this point, we're going to fire off a request to dinner agent with the prompt, the sender name and the content that we just got back. So what is dinner agent? Well, dinner agent is defined as a new agent that accesses the language model provided by Anthropic, and Anthropic in this case actually comes from the Vercel AI SDK. I know, hopefully we can get Convex up on Tanstack AI soon. Currently, you need to use the AI SDK, but other than that, it looks like a standard LLM interaction. You've got your system prompt, you got your tools defined by create tool, and then all the way down the bottom here, we define our dinner agent with a name, and then some tools like search restaurant, get restaurant details, add and remove from the short list, show on a map, which is a client side tool, and then highlight shortlist item, which is also a client side tool. So let's talk about tool calls next, because tool calls are the only way to really do anything cool with an LLM. Without tool calls, an LLM just knows what it knows. It's tool calls that allow it to then go and actually effect change or make queries in the real world, like for example, searching for Greek restaurants. So how does this actually work? Well, there's actually a kind of choreographed little dance that you have to do with the LLM. And in this case, the AI SDK from Vercel is actually going to handle that tool calling dance for us. So the dance starts when the browser sends the message with the @AI. That goes the agent. We then do the stream text. That adds that message to the messages array that it then sends to the LLM. It also sends the list of tools along with the list of messages. The LLM then recognizes, oh, I think I need to make a tool call in order to get the data, but it's not actually going to do the tool call itself. It adds a new specially formatted message to the messages array that says, hey, you should make a tool call, this search restaurants tool call, and then put the result back in the message transcript and send it back to me, at which point I'll look through it and then format a markdown message that actually explains like what I think would be a good idea, where you should go and eat. So it starts over here in the dinner agent when we say that we have the search results tool, and then the search results tool. So it starts over here in the dinner agent where we have the search restaurants tool, and then the search restaurants tool. You define it with a create tool and you give it a really good description. That's critical. You need to tell the LLM when and why it should call this function. And then you give it any arguments that it needs to specify. In this case, it would be the query. And again, you should be really descriptive about what the LLM should send in for that argument. And then you've got your handler. And your handler, honestly, in this case, is really easy. All we're going to do is use the convex run action that's in the context to then call this search nearby internal. And search nearby internal is just going to use the Google API to go and get the places and return that data, which is then going to be JSON packaged and sent back to the LLM in the message stream. And then transactionally, that's kind of right about here. And then the LLM is going to take that JSON payload that has the results in it and then format markdown which is what we see. The other interesting interaction here is when you add an item to the shortlist. So let's say again, I want the AI to add Thai vintage to the shortlist. And now we can see that we've added it to the map, and also we've added it to the shortlist. So how does that happen? Well, we go back to the code over in the dinner agent. There is a tool for add to shortlist. That tool has a great description as well as arguments, and it's going to run a mutation to say, I want you to add to that shortlist, and that's an internal mutation. So that means that only, and then it's going to run a mutation that adds, and then it's going to run the add internal mutation on shortlist. So it's going to go and add that restaurant to the list. Now, the cool thing here is that that internal mutation can only be run on the server, which is where this code is running. So that's a great way to secure the API service of your application. Let's go take a look at add internal. So add internal simply does a DB insert, just like you would in any normal database. This just happens to be a real-time database. And then over here in our components, under shortlist, you'll see the shortlist panel. That's this panel right down here. And it's got a use query that simply subscribes to that shortlist. It also has mutations for voting and for removing, and it uses the convex use query on the shortlist list. That's actually a subscription, so that whenever that shortlist changes, it updates automatically. So that's that real-time database system in action. All right, well, I hope you give this a try. Download the code for yourself, throw it on your Claude code, and get it to do whatever kind of multi-user AI-enabled chat you want. Let me know in the comments if you do that. In the meantime, of course, thank you so much to Convex for sponsoring this video. If you like this video, then hit that like button. If you really like the video, hit the subscribe button and click on that bell. You'll be notified the next time a new Blue Collar Coder comes out.